Yes. So this is a problem is given. The one simple problem for the overtaking side distance. So what they have mentioned that determine the overtaking side distance on a highway for the design speed, capital V is given, the design speed of 100 km per hour. Assume appropriate data from IRC recommendation. Also specify minimum and desirable length of overtaking zones to be provided if necessary. Okay, so this isn't a problem. Only the one data has been given, which is nothing but the design speed of the road 100 km per hour, and they have not specified anything about that one-way traffic or the two-way traffic. Okay, so but we are assuming it is the two-way traffic, opposite vehicle also coming. So the default assumptions we are making and we are doing actually. So this is an assumptions we have to take while solving this particular problem. Since there is no other data has been given, so we will assume all the data. But before that, I already defined what will be the equations for the overtaking side distance. So which is defining as an OAST is equal to 0.278 into speed of the vehicle B into reaction time plus 0.278 into VB into D plus 2S. So this is nothing but what I have shown, BS plus 2S. D2, and this will be the D1. Then the third component is nothing but opposite vehicle. So opposite vehicle is coming in the speed of the design speed and travel time is T. So this is the D3. So when we are trying to add all the three components, we come to know what will be the what we can say overall overtaking side distance. And here the problem, the design speed is given as an 100 kilometer per hour. For estimating the VB, I have already told that 16 we have to reduce it. So 16 kilometer per if you are reducing, so that will be the speed of the overtaken vehicle. So this assumptions, this calculations we have seen during the last derivation itself. In case if it is meter per second, 100 minus 4 we have to provide, the value will be there in the meter per second, maybe the 50 or the 40 minus 4 if you are putting what will be the overall speed in the meter per second. So that will be getting from this particular assumption. Then the reaction time is nothing but 2 seconds for the overtaking side distance. When it is coming to the SST, I told that you have to assume as a 2.5 second. But here the decision is taken as an overtaking, not for the stopping. So that immediate action is required to cover that minimum gap to complete that overtaking behavior. So that is the reasons we have reduced that overtaking side distance with respect to the reaction time as an 2 second. Then what are the components required in this particular equations? I told that the equations for the S is nothing but S equal to the 0.7 into VB plus 6. So you might be getting what will be the value for the S. VB is nothing but we have estimated as an 84 into 84 plus 6. If you are multiplying, you come to know what will be the S value. So S is estimated VB already estimated 84. Then the T, the parameter capital T, that means the vehicle B traveling from the B1 to B2. So what is the things that is estimated? So the equations for the T, we derived 4s divided by a root square. So this is the things we have a given 4 into s you have a calculated a for the 100 kilometer per hour. The table I have shown from there. If you are taking the value is 1.92 kilometer per second. So this is the range you are getting for the t value. So now we have all the data. VB is nothing but 84, T is nothing but the 2 second. So all the values we try to apply. So OST, yes. Okay, so OSD is nothing but 0.278 into VB is nothing but 84 kilometer per hour. Reaction time is 2 seconds. Then 0.278 into VB is nothing but 84 T. What is the S value?
64.8.
64.8 is coming as an S value. T value. So here you can apply 64 into 8. T value.
Sir, one doubt, sir.
Yes.
Sir, like in the test you gave like 0.7 VB plus 6, no, sir?
Yeah.
So in that is VB the unit is meter per second or kilometer per hour, sir?
This is a spacing. This is a meter.
Okay, sir.
Okay. What is the value for T?
It's 11.61.
Okay, 11.61. This is a time, so it is coming under the second. So now you have all the value. You try to apply 11.61 plus that another component is 2 into S. S is nothing but 64 into 8. So S is nothing but the space. So it is coming under the unit of meter plus 0.278 into, this is an opposite vehicle. We assume that it is coming under the design speed. So the design speed is nothing but 100 kilometer per hour. The time it is taken B1 to B2 is nothing but 11.61 second. So this will be the D1 and D2 component. This is T2 and this will be the D3. So maybe just to separately calculate what is the D1, D2, D3. Here's my calculator. So 0.278 into 84 into 2. So I'm getting 46.704 plus 0.278. D2 you can calculate 84, 11.61 plus another component is nothing but 2 into 64.8. 400 I am getting. 400.72. So you can also check in your calculator. 0.278 into 100 into 11.61. 322.758. So this is the value I'm getting, and the overall stopping overtaking side distance when we are adding all these three components. So we are getting approximately 771.82 meter. So this is an overtaking side distance when it is coming to the 100 kilometer per hour as an design speed. with the assumptions of two-way traffic, opposite vehicle also coming. So this is in a solutions for that determine the overtaking side distance. At the same time, what they have a provided some zones we are assumed overtaking side distance zone. So what happened in the sense when normally when we are planning to design what we can say the highway, we used to provide this stopping side distance as one of the considerations. Sometimes some road we might not be getting that frequent structure of overtaking behavior. So example 10-kilometer road is there. It is in a narrow road where we are highly getting the difficult for the overtaking behavior. So in that time what the design what we used to do in the sense is the 5 kilometer. So we might be breaking first 2 kilometer. After the 2 kilometer, we are exclusively providing the overtaking side distance by widening the road or some other facilities while providing. So where the road is not possible to provide the overtaking side distance in a default design aspect, as the transportation designer and the planner, we are providing the overtaking zone. You might be definitely seeing this signboard in India while traveling in some of the arterial or the subarterial road. That exclusive overtaking zone is defined with respect to the minimum overtaking length and the maximum overtaking length. So that is nothing but the minimum overtaking zone value and desirable overtaking zone value. So what we are doing in the sense, the same calculations we are doing once we estimated that OST value, the minimum OST is estimated with respect to the thrice the normal OST. So this minimum value you have to provide it. Maximum what we can provide, that maximum or desirable OST is nothing but 5 times what we estimated from the OST. So this is in a buffer zone we are giving minimum to maximum. This buffer is given as an maybe x1 x2. Okay, so this is we are giving as a design criteria to implement the overtaking side distance where we have not provided the OST in the throughout the stretch. That overtaking zone is defined with respect to this kind of situation. So maybe this is in a stretch we are going, okay, and suddenly what happened, we are providing the overtaking zone. Then the overtaking is completed, again we are continuing. This is in a one direction. The same road opposite direction is coming and overtaking zone is started. Then we are following that overtaking zone, then it is ending and it is coming to the normal, what we can say, road. So this is a design of overtaking zone. So this is varies between the x1 to x2. If they are asking design the overtaking zone at the end, you have to estimate what will be the minimum OST, maximum OST. So example what it is coming into 3, if you are putting 2310, 770 into 5, if you are putting 3850. So this overtaking zone is designed 2310 to 3850 meter. So this is a way we are designing the overtaking zone. So hope you might be getting how we are designing or defining the overtaking zone. So any doubt from this particular problem? It is very simple. Once again, I'm just explaining the same problem. Determine the overtaking side distance with the design speed of 100 km per hour. They have not given any other data. So we have to assume as per the IRC standard. Also, they ask us to design the overtaking zone with respect to the minimum and the maximum desirable length or the maximum length of the overtaking zone. So we assume the opposite vehicle is coming The OST is nothing but the add of D1, D2, D3. And what are the parameters required? Design speed of the vehicle B. But the problem, design speed is given. The traveling speed of the vehicle B is estimated 100 minus 16. That means design speed minus 16. When you are putting, you are getting as a value of 84 kilometer per hour. And the reaction time is 2 seconds. When you are multiplying both value, you get the value of D1. So D2 is nothing but yesterday we have derived B plus 2S. B is nothing but 0.2798 into speed of the vehicle B, the time the vehicle traveling from the B1 to B2, that travel time is considering as a capital T. So we need the value of T, yes. S is nothing but 0.7 into VB plus 6. So this is the distance between the B1 and B2. So BB is 84 when you are applying. So you come to know spacing between the B1 and B2 is 64.8 meter. Also, we derived the equation for the capital T. Root of 4 is divided by A. S is 64.8. A, we assume 1.92 for the 100 kilometer per hour. When you are applying, the time is we are getting as an 11.61 second. So while applying all the value, including the speed of the vehicle B, you come to know D2. So D2 is nothing but 400 meter. The final one will be the opposite vehicle C. That equation is nothing but capital V into T. So T we know capital V is nothing but the design speed, and when you are trying to multiply all the value, you come to know D3 is nothing but 322. So the total OST value is approximately 770. Other than that, you have to design the overtaking zone. The overtaking zone is nothing but where the provision is not provided. The overtaking is strictly prohibited in that particular corridor, 5 kilometer or the 10 kilometer corridor. But obviously the fast moving vehicle will be the right to permit that fast moving vehicle to overtake the slow moving vehicle. We exclusively providing the overtaking zone. So the design of the overtaking zone is minimum of OST and the maximum of OST we are defining. So that is nothing but 3 into OST, the minimum OST value. Maximum is nothing but 5 into OST. So the value is supposed to be between these two. Maybe I assume or I fix 3000 meter or 3500 meter. So this length supposed to be lies between 2310 and 3850 meter. So this is the way we are designing the overtaking zone. So hope you are getting this simple problem, and it is a highly expected problem also, whether the stopping side distance previously we have seen in the last class or the OST, or followed by we are going to see some more parameter. So definitely the whatever the competitive exam you are going, two questions definitely it will be there from the second unit itself. So mostly the problem will be there, else some of the what we can say logical questions, some of the tricky questions, the theoretical part questions also sometimes they might be asking. So this is the things with respect to the what we can say OIST. And I think not now 2000 I think 10 or 6 something, and they were asking the simple questions. They given the data, they were asking the minimum and desirable length of the overtaking zone. So this is one of the straightforward questions they were asked in the gate exam, and followed by the same questions they were asking little bit the tricky manner. So maybe next problem I will show. So there you can able to get little bit confusions. So the speed of overtaking and the overtaken vehicle. So the overtaking vehicle is nothing but A, it has been given. The overtaken vehicle is given as an 40 kilometer per hour. So you know what will be the V value, what will be the VB value, it has been given respectively on a two-way traffic road. So it is given as a two-way traffic road. The average accelerations during overtaking may be assumed as 0.99 meter per second. So they given that A value also as an 0.99 meter per second square. Okay. Calculate the safe overtaking side distance. OST, they were asking what will be the minimum length of the overtaking side distance. 3 into OST. Draw a neat sketch of the overtaking zone and show the portions of the signboard. So this is the things they were asking, where to keep the signboard and what will be the overtaking stretch. So that is they were asking. Okay. So basically, I will tell where to fix a signboard. Okay. So this is an overtaking zone as starting point, correct? So before stopping point, before the 770 meter, so one OSD distance, here we are fixing our signboard. Overtaking zone is going to start. So this is the place you have to fix your signpost 1, where you define the zone is going to start. At the same time, you have to explain where it is going to end, right? So in case if you're providing 3000 meter as an overtaking zone, before 770 meter, you have to fix another signboard as an SP2, where you have to explain that it is going to end overtaking side zone. Sorry, overtaking zone. So this kind of the signpost you have to keep before 770 meter. At the same time, the opposite vehicle also same criteria. Before 770 meter, signpost 1 you are keeping, and before 770 meter, signpost 2 you are keeping for the opposite vehicle. So it is simple and it is easily rememberable. So that things only they were asking. Draw a neat sketch. This kind of the stretch you have to draw and you have to explain where you are keeping your signpost. This is one thing, extra thing we can learn from this particular problem. Other than that, what the tricky part they have a given in the sense, the vehicles, everything is given as a kilometer per hour. Okay. So, but here the overtaking, while the overtaking, they have a given the value of accelerations in meter per second square. So that can be, has to convert to the, what we can say, kilometer per hour per second. So this is a conversions, it has been defined in that IRC, and basically we know the conversions value is nothing but 0.278. So when you are trying to divide 0.99 divided by 0.278, and you might be getting the value of 0.99 divided by 0.278, the conversations while it is happening, the value is 3.56. So the value of A is 3.56. So this is in a one way, what we can say, you can convert your value to the standard, or the, what we can say, all the unit as in a common unit. One way you can make this changes and apply in the equation. The second way, what you have to do in the sense, the speed 70 kilometers given, 40 kilometers given, that can be converted as a meter per second. Okay, you are getting how to change that value. So kilometer per hour you have a given, that can be converted as a meter per second. Then you have to modify the equations accordingly, then you have to estimate it. So both side is feasible, but it has to do it right. That you can able to add the meter plus meter only, meter per kilometer you cannot add it, right? So that is the reasons this conversions are happening. Once this changes, if you make it, then you can able to estimate what are the value you are getting. Okay, so it is simple as in a previous problem only, that OST equation is nothing but D1 0.278 into speed of the vehicle into T, reaction time. Next 0.278 into VB into time traveling from V1 to V2 plus 2S. This is nothing but your D2 plus D3 is nothing but 0.278 into V into T. So this is nothing but D3. So VB is value for the, okay, I will write here. VB is nothing but 40 kilometer per hour. Capital V is nothing but 70 kilometer per hour. Reaction time is nothing but 2 seconds. A, the value what we were estimated is that 3.56. So this is an A value we have estimated. Now what we have to estimate in the sense, S value you have to estimate, as well as you have to estimate for the capital T value. So S is nothing but 0.7 into speed of the vehicle B plus 6. So 0.7 into 40 plus 6 if you are putting, you come to know what is the value for S. Then the T is nothing but 4 into S divided by A root square. So 4 into S value divided by, A is nothing but 3.56. If you are putting the root square, so you will come to know what will be the T value. So now you have all the value and you apply all the value, you come to know what will be the overall overtaking side distance. Overall overtaking side distance you will be getting as a value as a meter. So once you estimated, then they are asking what will be the minimum length. Minimum length of overtaking zone is nothing but thrice the value OST what we have estimated. So this is the value you are getting. So you just use your calculator and let me know what will be the OST value and minimum OST value. Then we will design overtaking side zone. So this is the range it is going. Then we are providing the overtaking zone. At the same time, opposite direction. This is the things it is there. So here we are placing overtaking signpost 1. And here we are keeping signpost 2. The same time here opposite vehicle signpost 1 and signpost 2. So what will be the distance that we have to give? So what is the S value?
34.
Can you little bit louder?
34, sir.
34. So 34 meter. Anybody estimated the value of T?
6.18.
6.18 second. Okay, then estimate the OST. Anybody estimated, or you can estimate? So apply all the value.
So 279.22 meters.
279. Okay, approximately 280 it is coming. So 280 into 3, how much it is coming?
840.
558.44, sir.
Into 3, 278, right? So this is a 279 you are getting as an OST value, right? Then it's supposed to come 800 something into 3 when you are multiplying, right?
Sorry, sir. 837.
Okay, 837 meter. So this is a minimum OSD. The problem itself, they were asking only the minimum length. So maybe we can designs with respect to the overtaking side, so overtaking zone. So this is an overtaking length. We are assuming as an 837 meter. So this is the length 279. So maybe the zone is starting from here and ending here. Total length is 837 meter. And before the 278 meter we are giving the notifications. This is the things, and where this is we are posting in the sense from here to maybe 837 you can subtract 279, then this length will be the 558. So this is the distance, okay, overtaking zone, the first part, then they are getting the post, sign post, then again they are traveling for the 279 meter. The same in reverse we are providing from here to here 279 meter. The first sign post we are placing, from there it is traveling for the 558 meter. We are giving the second sign post and the ending distance is 279 meter. So this is an overtaking zone we are designing by considering the minimum length of overtaking zone, which is nothing but tracks the OST value, also where to fix the signpost. So it's a simple problem, and sometimes the main tricky point is nothing but the unit. So it make a lot of conflict as well as the confusions. So before going to use that particular equation, make all the assumptions variable as well as the given variable in a single unit. So most probably the so far what I experienced, it is coming under the kilometer only, the question paper also. Sometimes the tricky manner they might be giving that meter value, so that you easy to convert as an a kilometer. Then you apply the given equations. Okay. So this is the things with respect to while you are converting your unit of the A, nothing but the acceleration. Another part what I have told you in the sense, the vehicle kilometer per hour, it is given the speed that can be converted as in a meter per second. In that particular point of view time, what happened, all the equations will change. The 0.278 here it won't come, it is a directly VB into T plus VB into T plus 2s then V into D. Those those values 0.278 it won't come while estimating. So directly you can apply it, you will get all the value of the OST. Okay, so this is the things. So how we are estimating that value of the overtaking zone. So yeah, anyway here, any doubt students? Here we will conclude the today's session's overtaking side distance. In continuation of that, two more parameters is there: highlight side, headlight side distance and intermediate side distance. It is very simple only. So tomorrow we will solve that particular problem. Followed by we will move to that another important highway design element is nothing but horizontal curve. So definitely it will be interesting like a side distance problems. So in that interesting way we can continue that second component also. So any doubt from the today's session? So today we have a seen and overview the overtaking distance, OSD value, overtaking side distance, and very detailedly we have seen two problems how to solve that OSD value and how to design the overtaking zone by considering the minimum as well as the desirable, that is nothing but the maximum overtaking zone length. Any doubt student?
Sir, in the first problem,
Mm.
like for the calculation of t, we use under root of 4s by a, but then in the last week, you just gave a table to us which says that for 100 kilometer per hour, a value is 0.53.
0.
So here
Yeah.
53.
Okay.
So here we use 1.92. So which one should we use?
No, you just take what is the assumptions given for the 100 kilometer per hour as per IRC
0.53 is given for A.
Okay, student. Then you just take 0.5. No, that 53 is what I have given in the sense meter per second square. So that 53 has to convert towards that kilometer per hour. that conversations what I told in 0.53, maybe you have a calculator, you try to apply 0.278. Okay, 0.53 you convert divided by 0.278, you will be getting 1.906. I'm getting 0 for 1.90647 I'm getting. So last table, whatever I have given the meter per second square. So maybe here, not for this problem, I will give that IRC value probably. So all the values what I have given is the meter per second square. So we have to convert, because your problem everything is given as in a kilometer. So that kilometer conversions, when it is happening kilometer per hour, you have to convert, and this second, this is a maximum overtaking accelerations as per IRC given. So 0.53 for the 100 kilometer. So you have to divide 0.53 divided by 0.278, and you are getting the value of 1.06. That's the reason I assumed 0.91 or the 92. So that is the value I have taken. So the table whatever I have shown, you just convert that value, if because all the problems we are solving with respect to the kilometer. So here also it is given as a meter value. So converting, so I have a divided that value. So we got it. So likewise, you try to convert the table for the both with respect to the meter as well as the kilometer. Okay. So you are getting what?
Sir, I have
Yeah.
another doubt, sir.
Yes.
Sir, in the second sum, we've written S equal to 0.7 VB plus 6, no, sir. So
Yeah.
that VB we've mentioned in kilometer per hour. So S value will be in kilometers, no, sir. So why is it 34 meters?
No, this equations, that's the reason that during the derivations, so I'm not going much details about that derivations. Okay. So that is the reasons this 0.7 coefficients we have a provided. So the value kilometers we have a taken, some detailed derivation is there, which is not part, and also it is not recur. So that is the reasons directly I have given this equations, and the coefficients we have introduced according to that point of how we are converting that unit. Okay.
Okay, sir. So in T, we have given us the root of 4s by a, and S is in meters, but a is in kilometers per second square, sir. So how, like, meter and kilometer will be there? Like, it should be both in same meters, or both should be in kilometers, no, sir?
Okay. Meter, and it will be in the kilometer per second. Right. Okay, this is also some little bit calculation is there. Maybe in the next class I will see how the derivations are happen, conversations. Maybe I will float it. Okay, so instead of going in the detail, I will add on the PPT. I will give it little bit. It is a lengthy one. Okay, but it is not part of your curriculum. Okay.
Okay, sir. So in the S, when we're taking 0.7 VB, that VB should be taken always in kilometers per.
Kilometer. Yes.
And A can be taken. A should be taken in.
A also should be the kilometer per hour. Okay.
Oh, okay, sir. Sir, and one more thing, you mentioned that OSD will be given by D1 plus D2 in some special case. So, sir, which case is that?
Here they have mentioned two-way traffic, right? So the road stretch is there. The opposite vehicle also, if it is coming, then D1 plus D2 plus D3. If the road is allowed for the only one-way traffic, then there is a no point of the D3. C vehicle won't be there. So that time D3 becomes 0. Or you assume that you might be travel Palpane junction to NIT Tiruchi. So we have the median. Okay, so this is just going and overtaking. That time we are not any influenced by the opposite vehicle. So if there is a median also present, then D3 become a 0. So you have to read the problem carefully, whether it is a two-way traffic, one-way traffic, or the highway with median. With the median, one-way traffic, D3 becomes 0. If the only the two-way traffic is allowed, then D3 you have to estimate it. Got it?
Okay, sir.
So any other doubt, student? This conversation, that is the reasons I have floated all the problems with respect to the direct equation. Not few, we have to cover so many parameters, design elements. So everything, if I'm taking the derivations and explaining, it is highly difficult to cover all the portions with respect to the problem. So anyway, the appropriate materials I will float it. You just to go through it, the content, how it is derived. Okay. Okay. Any doubt, student? So yeah, definitely, as I mentioned that your exams, competitive exam, definitely one or two problem will be there from this particular unit. We can expect one problem from OST or the SST. Another problem will be that horizontal or the vertical curve. So which we'll be covering and following classes. So then thank you everyone. See you tomorrow.
Okay, sure.
Yeah, thank you everyone once again. I'm ending the session.